Hi there everyone, my name is Marco Simoni, I'm from Rome and I'm here presenting this video as a presentation for the Innovandi Nanocem as best PhD student in cement science. And well, what was my PhD about? This video is supposed to tell you that. So it is about an alternative route for the calcination of calcium carbonate, which you'll know that is a carbon emitting process. It's conventionally made through thermal heating, and the PhD I did was focusing on a chemical calcination of calcium carbonate by using the concentrated sodium hydroxide solutions, and to basically convert calcium carbonate to calcium hydroxide or portlandite and sodium carbonate. So the trick is that while we calcinate calcium carbonate, we also trap just the process CO2 emissions whilst avoiding the combustion CO2 emissions. It's been a very long journey. It was a 4 years PhD. It was just packed of adventures and learnings, a lot of knowledge that I acquired throughout the road, and it's all justified by the 5 research papers that I published in one was in cement and concrete research as well. So everything was very good, and the research papers were mainly focusing on those parameters which optimize the yield of the reaction, because it is a breakthrough process which is going to renovate the cement production line. And that is to say that we had to focus on those parameters which might affect the economy of the process itself. So that's why we decided to go through first a paper which introduces the technology and the first trials we attempted. Then we went through, I say we because it was a team, it wasn't just me. It was me and my supervisors who did this. And so we did decide to go through the first paper first, and then the second one was about mixing rate and mixing speed and the resident time as well of the reaction, to see how long we needed for the reaction to be complete to produce portlandite and sodium carbonate. Then after that we did investigate the effect of temperatures, and therefore we also detected the activation energy for the reaction to carry on. Then we also investigated the effect of some impurities, key impurities that you can find in calcium carbonate industrial grade materials. And then, last but not least, we also produced a review paper which basically compares the carbon capture and storage technology which are now available on the market with our technology, which is yet a technology to calcine calcium carbonate, but also a carbon capture and storage technology which prevents the storage of liquid CO2, which is the aim of basically all the carbon capture and storage technologies. We, instead of storing liquid and high pressure carbon dioxide below the ocean, which we don't know the fate of these routes, we're just gonna convert it into a solid product, which is a mineral sodium carbonate. So basically this is a kind of very rough overview of what I've done throughout my PhD, apart from other side projects. And why do I have this background here? Well, because apparently, these research projects, those research papers that I published were useful, because actually somebody noticed it, and I said, okay, cool, this is smart. Yeah, we want to upscale it. And so they hired me. I'm just now working with a startup which is willing to, upscale the process from lab scale to kilogram to ton scale. But remember, always. So, no matter what you do, no matter how you do, safety always first.
Boo.
Help!